The IISc's new Center for Nanoscience and Engineering, or CeNSE, is designed to take researchers beyond the limits of human senses. Here, the human eye is augmented with electron microscopes that scan nanometer-scale structures, and the fingers that deftly manipulate these structures are composed of beams of laser and electrons. Inside the center's sprawling 10,000 square foot nanofabrication facility, human skin is enclosed in overalls that arrest minute skin flakes. Gauging pressure, temperature, acidity, salinity, and other parameters is a job entrusted to hundreds of miniature sensors, relaying real-time data to the facility's computer monitoring system. The center's futuristic infrastructure, extending human senses and capabilities, is a prerequisite for creating smart nanostructured products to serve widespread Indian needs from tomorrow on. A year and a half after its inception, nearly 70 PhD students, 40 multidisciplinary faculty, and 50 project scientists here pursue the center's unique mandate to conduct fundamental research and simultaneously to develop indigenous nanotechnologies for healthcare, agriculture, renewable energy, defense, and other industries.
There is research, there is innovation. Research is generating new knowledge. Innovation is deriving economic value or societal benefit from that knowledge. And that is the way one develops technologies. So what will happen here is that some of the people who are working here may like to start their own industries, startup industries. And also it's very likely that this center will be an incubation center for the large industries across India, perhaps across the globe.
In addition to research and innovation, the experience gained in setting up CeNSE's National Nanofabrication Center, or the NNFC, is now a vital developmental resource for the entire country. CeNSE's design faculty spent nearly 7 years in designing, constructing, and commissioning the NNFC based on international benchmarks and Indian requirements. This expertise in mega engineering is being shared by the design committee through consultations and an educational video series about the NNFC's salient features. These include a ballroom design for the clean room with the flexibility to conduct multidisciplinary experiments, a 3-tiered vibration-isolated architecture, the provision of 30-odd gases and many specialty chemicals, a clean room with air filtered and conditioned to nanofabrication specifications, continuous power, deionized and chilled water and other utilities, state-of-the-art process equipments, and an eco-friendly footprint. The NNFC is supported by a 4,000 square foot micro and nano characterization facility. The MNCF has 4 suites of advanced instruments to examine a device's electrical, mechanical, optical, and material characteristics. The excitement and confidence that CeNSE's facilities induce in nanotechnology researchers can today also be seen in its users from Indian and international research initiatives such as the DRDO's National Program on Micro and Smart Systems, or NPMAS, and the Indo-US Solar Energy Program.
CeNSE has made some very innovative ways by which they can facilitate the interaction between the academia and the industry. They have realized that the industry cannot take a research innovation and convert it into a product innovation without having been involved during the research stage itself. So they have worked with many industries to ensure that they are present in CeNSE and participate in the research also.
Equally promising is CeNSE's rollout of the Indian Nanoelectronics Users Program, involving young researchers from universities in India and abroad. CeNSE's INUP researchers have already published over 50 scientific papers, and in the first 3 months of 2012 alone, prospective participants submitted 33 proposals for advanced research.
CeNSE faculty are also involved in many of the other major national network programs, and I think they have a great obligation really to facilitate meetings, workshops, training programs for students from elsewhere. Because I think eventually what India would need is a very large number of people who are trained to use these facilities, who are talking the language that the faculty members in this department are talking.
The gathering momentum of activities at CeNSE can now be leveraged to swiftly expand India's nanotechnology base to a scale commensurate with global efforts. The researchers of CeNSE are now rededicated to facilitating this development at CeNSE and beyond.